If you are concerned about having high alcohol in your kombucha, this is the video for you. Whether you are a person just making kombucha for fun in your kitchen and you want to give it to your kids and not worry about alcohol, or if you're a commercial producer, this video is going to be helpful. My name is Nick. I've been working with kombucha brewers for over 7 years now with hundreds of kombucha brewers all around the world. And my PhD is in bioengineering, where I studied yeast. So hopefully this video is helpful for you, and I will just cut straight to the chase. The easiest thing, the number one thing you can do to reduce alcohol in kombucha and improve consistency is using a very old starter. So what that means is you have your primary fermentation with, just a cloth on top with the SCOBY, but you have a separate fermentation for your starter culture. And the way that you do that, or the reason that you do that, is because you want your starter culture to be at a very, very low pH. You want it very sour, like vinegar, and it's going to have a lot of bacteria, not many yeast, and it's going to reach a steady state by sitting in that condition for so long. So ferment your primary fermentation for like a month or two, and you have a very stable starter culture. Some people make like a SCOBY hotel and store their SCOBYs in there. That starter is going to greatly reduce your alcohol in your primary fermentation, and it's going to greatly improve your consistency. So I want to explain to you why that is, and the reason why that is going to help us with other methods to reduce alcohol in kombucha. There are two groups of organisms that live in a SCOBY, symbiotic colony of bacteria and yeast, right? You have yeast and bacteria. The yeast consume the sugar and produce alcohol, and the bacteria consume alcohol and sugar to produce acids. So this is the cycle that's going on here. The yeast and the bacteria have different metabolisms and different physiology and some physical differences as well. And that's how we're going to reduce the alcohol. We really want to have a lot of bacteria and not many yeast, or reduce the activity of the yeast and increase the activity of the bacteria. Now, if you've already got your gears spinning on why that old culture is good, it's because the longer you brew, the more sour the kombucha becomes. It becomes more and more acidic, so those bacteria can live really well and those yeast can't survive as well. The bacteria can survive those lower pHs and the yeast cannot. So you're going to have mostly bacteria that you're starting with and not many yeast. So as soon as that small amount of yeast produces a little alcohol, it's going to be pretty quickly converted to acids by the bacteria. So that's generally why, or a big part of why, that method works. A couple more differences between yeast and bacteria. Yeast are about 5 to 10 times as big as bacteria, so you can physically separate them potentially. Yeast in general prefer slightly lower temperatures. It really depends on the species, though. You can't really make a blanket statement. Everybody's SCOBY is different. Some bacteria can live and grow happily at 50 degrees Celsius. And so can some yeast, and vice versa. There are some very low temperature bacteria and low temperature yeast, but generally yeast like a more moderate temperature range, and bacteria can handle the more extremes. Again, depends a lot on your species. So size, temperature, pH. Another thing to think about is the oxygen amount. So yeast and bacteria can grow in aerobic or oxygen-rich conditions, but yeast grown in aerobic conditions produce about 30% less alcohol than in anaerobic conditions, roughly, somewhere around there. The bacteria love having oxygen. They need the oxygen to survive, and that's why kombucha is kind of weird. It's an aerobic process. You have a cloth on top that allows the air in because the bacteria need it in order to live and then produce that pellicle, that bacteria nanocellulose layer on the top of the kombucha. So in order to increase the oxygen in your fermenter, in your primary fermentation, you have a couple of options. One is you can change the aspect ratio, so the ratio of the width to the height of a vessel. So if you have a very wide, flat container, then you have a lot of surface area relative to the volume. Whereas if you have a tall, skinny container, you have a small amount of surface area and the same amount of volume. So increasing the aspect ratio, having a very wide flat container, it's gonna produce pretty sour kombucha. Anything we do here is gonna change the flavor. You just have to do the experimentation to see what works with your SCOBY and your environmental conditions. So the aspect ratio, you can just brute force it and blow air into your kombucha, and that achieves multiple things. Again, you know, aerobic conditions are going to slow the alcohol production metabolism. It's going to increase the acid production metabolism, and it's actually going to evaporate some of the alcohol. The alcohol is going to preferentially leave rather than water as dry air is blown through the kombucha. You do need pretty high airflow rates to have a noticeable effect. Something like 1 liter or 2 liters per minute, given like a 4 or 5 liter vessel. So like an aquarium pump just hooked up and blowing air through your kombucha. Again, this is gonna give different flavors. All these changes we make are gonna change the flavor. So those are the major changes you can make on the primary fermentation, using an old starter, changing the aspect ratio of the vessel, blowing air through your vessel. In the secondary fermentation, there's a few other things that you can work on to reduce alcohol. A lot of brewers get residual alcohol production even when their product is sitting in the fridge. So you really need to watch out during that bottling process or secondary fermentation, whether or not you put it straight in the fridge and force carbonate it, or you let it naturally carbonate. You need to watch out for this. So one, you can do some sort of filtering. Even just getting rid of some of the sediment is useful for controlling shelf life. A lot of people are sensitive to consuming too many microorganisms. You know, if you're a crazy kombucha person like we are, maybe your body is accustomed to having a lot of microorganisms, but most consumers aren't used to that, and they could have stomach issues anyway. So might as well filter your kombucha at least somewhat. You don't need a 5 micron filter to filter out all of the yeast and keep just the bacteria, even though in theory that should work. Just getting rid of some of the sediment is helpful in my experience. Another thing to play around with is the flavors that you add. I've heard that there are certain flavorings that will reduce the alcohol content. I don't know if it was cinnamon or ginger or something, allegedly reduces the alcohol content in the bottle, or prevents bacterial or yeast growth in the bottle. That would be pretty cool. I've worked with a brewer that had 2 different flavors, exact same primary fermentation and process. One flavor brewed at 0.2%, one at 1.2%. Gotta pay attention to your flavorings. It's gonna change how your kombucha brews. So make sure you filter if you want to reduce the alcohol, different flavors. And those are the 2 big process improvements you can do for the secondary fermentation and the bottling to improve shelf life and reduce alcohol. So just short plug, I make alcohol detectors for kombucha brewers. I've been doing it again for 7 years. I do consulting for kombucha brewers as well, but the alcohol detectors are really awesome. You know, I was brewing kombucha years ago and I built these machines because I needed it. And now 300 kombucha producers all over the world use my machine. So hopefully this video was helpful. If you have any tips or tricks for yourself, leave them in the comments below. I would love to take a look at them, and I'm sure everybody who watches this video would love to take a look. My final tip is you gotta measure the alcohol. You gotta measure to know how much alcohol is in your kombucha, and you can do that with gas chromatography, with lab testing. I would highly recommend that. That's always going to be the best way. The second best way is with my machine. Hydrometers do not work. Measuring the density before and after, not going to give you accurate results. I promise you. Send it off to a lab, do the hydrometer test. They're going to be vastly different. So again, I really hope this video was helpful. If you enjoyed, leave a like, pass it on to your kombucha brewing friends. Thanks for watching. Bye.